Streamlining Terraform State Management, a centralized approach with CDKTF, AWS S3, and DynamoDB. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction to Terraform State and its importance. Terraform, an infrastructure as code (IAC) tool, is used to provision and manage cloud resources. As Terraform manages infrastructure, it keeps track of the state of resources through a state file. This file is essential because it stores information about your managed infrastructure, mapping your real-world resources to your configuration. With a proper state file, Terraform can determine the changes needed to align your infrastructure with your defined configuration. Therefore, managing this state file effectively is crucial to avoid conflicts, data corruption, and inconsistencies in your infrastructure. Why centralized state storage is essential. When multiple team members work on the same Terraform project, it's crucial to have a centralized location for storing the state file. Centralized state storage allows teams to collaborate seamlessly, ensuring everyone is working with the most up-to-date version of the infrastructure state. It also provides consistency, security, and an easy way to lock the state to prevent conflicts during simultaneous deployments. Building the state storage infrastructure with CDKTF. To manage Terraform state files centrally, you can leverage AWS services like S3 for storage and DynamoDB for state locking. Using CDK for Terraform, CDKTF, you can programmatically define and provision these resources, streamlining the setup process. Setting up the CDKTF project. Begin by setting up a CDKTF project. If you haven't already, install the necessary tools. npm install gcdktf cli. CDKTF init template equals TypeScript. This initializes your CDKTF project with the required structure and dependencies. Creating the S3 bucket. Next, create an S3 bucket storing the Terraform state file. This can be done within your CDKTF project by defining the bucket in your TypeScript code. Import subbucket from @cdktf/provider AWS/lib/s3 bucket. Const state bucket equals new subbucket this state bucket. Bucket Terraform state bucket. Versioning. Enabled true. Semicolon. Enabling versioning ensures that previous states are retained, providing a backup in case of any issues. Configuring the DynamoDB table. For state locking and consistency, you'll use a DynamoDB table. Here's how to define the DynamoDB table in CDKTF. Import DynamoDB table from @cdktf/provider AWS/lib/dynamodtable. Const lock table equals new DynamoDB table this lock table. Name Terraform state lock. Attribute name, lock ID. Type, S. Hash key, lock ID. Billing mode, pay_per_request. Semicolon. This table will ensure that only one Terraform operation can modify the state simultaneously, preventing conflicts. Implementing state storage in your CDKTF application. With the S3 bucket and DynamoDB table in place, configure your Terraform application to use these resources for centralized state management. Utilizing the subbackend resource. In CDKTF, you can configure the Terraform backend to use S3 and DynamoDB like so. Import subbackend from @cdktf/provider AWS/lib/backend. New subbackend this. Bucket state bucket.bucket. Key Terraform/state/terraform.tf state. Region, US West 2. Dynamode table, lock table.name. Semicolon. This configuration tells Terraform to store the state file in the S3 bucket and use the DynamoDB table for state locking. Integrating AWS provider. To interact with AWS resources, ensure the AWS provider is integrated into your CDKTF project. Import AWS provider from at CDKTF/provider AWS/lib/provider. New AWS provider this, AWS. Region, US West 2. Semicolon. This allows your CDKTF project to manage AWS resources in the specified region. Example, creating an SSM parameter. As an example, let's create an SSM parameter store entry. Import SSM parameter from at CDKTF/provider AWS/lib/SSM parameter. New SSM parameter this, example parameter. Name, /example/parameter. Type, string. Value, hello world. Semicolon. This demonstrates how to define and manage AWS resources within your CDKTF project, utilizing the centralized state configuration. Cleaning up resources. To avoid unnecessary costs, cleaning up resources after use is essential. CDKTF makes this easy with the following command. CDKTF destroy. This command will destroy all the resources managed by your CDKTF project, including the S3 bucket and DynamoDB table. Conclusion and next steps. Centralized Terraform state management is essential for collaborative infrastructure management, ensuring consistency and preventing conflicts. By using CDKTF with AWS S3 and DynamoDB, you can automate a robust state management system setup. The following steps could involve exploring advanced state management strategies, such as encrypting state files in S3 or setting up cross-region state storage for disaster recovery. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.